Hello everyone, in this video we are going to see about PN Junction Diode and its working. Okay, first we'll move the applications for PN Junction Diode. The PN Junction Diode can be used as a photodiode as the diode is sensitive to light when the configuration of a diode is reverse bias. It can also be used as a solar cell. The main application of a PN junction diode is it can be used as a rectifier in many electrical circuits. Okay, so we'll start. What is mean by a PN junction diode normally? A PN junction diode is a interface or a boundary between two semiconductor material, namely P-type and N-type, which is a type of a semiconductor. Okay, in the semiconductor, the PN junction is created by a method of doping. That is, the P side or the positive side of the semiconductor has more number of holes, that is, majority of holes, and the N side or negative side has the excess of electrons. So this is the unbiased diode. Normally, what is meant by unbiased diode here is without any external supply, without giving any voltage. That is the unbiased. Unbiasing is nothing but giving a voltage. So, before giving a voltage, how does the PN junction diode will be? Okay, in P type there will be more number of holes. In N type there will be more number of electrons. So, the charge carriers which has more number of electrons, okay, move from move towards the opposite direction. Okay, so the holes from the p type move towards the n type and the electrons from the n type move towards the p type. So what happens, since holes is a negative positively charged and electrons is a negative charge, they get recombined. Okay, recombined, so they become neutralized there. And here the p-type material is doped by using a trivalent. So we have acceptor ions. So acceptor ions is represented by a negatively charged ions, and in n type we will be using pentavalent impurities. So pentavalent, it will act as a donors. Okay, donors in the sense we have positive ions. Okay, so in beta we have negative ions, in n type we have positive ions. So what is the previous step we have explained? So the majority charge carriers, that is majority charge carriers. In p type we have holes and n type we have electrons. It gets recombined. Okay, it gets recombined and becomes neutralized. So there only will be at that end, there only will be immobile ions. Okay. Here there is an immobile ions. Okay, this region we'll call it as depletion region. In depletion region, there is a field, electric field occurring. There is a ions, right? So there will be an electric field occurring in that region. So the potential difference occurring in this region, we'll call it as barrier voltage. Okay, so we'll call it as barrier voltage. This is how it works in unbiased one. That is without any voltage is given, input voltage is given. Okay, and simply the concentration of hole which is higher, that is in p type hole concentration is higher, so it moves to the n type, and in n type electron is concentration is high, it moves towards p type. So what happens here is they get recombined and neutralized only, there will be an immobile ions. The region with immobile ion we call it as depletion region. And we'll come for forward bias. What is forward bias here is after biasing, after giving an external supply. And I have to add a point here. There will not be any current generation here because the majority carriers cannot move towards the depletion region. That is, the holes from the p type cannot move to the n type because of the depletion region. But the minority carriers can move from p type to n type. Okay, so keep that in points. So here, after giving the biasing, after giving the input supply, what happens here is forward bias. That is, what is forward bias here is the p type, that is positive side, is connected to the positive side of a battery, and n type is connected to the negative side of a battery. This one we'll call it as forward biasing. In forward biasing, what happens here is the positive, we have connected here positive, right? The positive moves towards the p type. Already we have excess holes here, that is the positive charge, and here also the positive charge goes to the p type. So what happens, we have excess number of holes here, and in here this negatively charged move towards the n type, while the electrons are majority. So what happens, it compresses, it pushes the depletion region to the lesser one. So the depletion region here becomes the lesser. So the diode start conducts after the barrier voltage, potential barrier voltage. That is for silicon it is zero point 0.7 volts, and for germanium it is 0.3 volt. Okay. After the barrier voltage, the diode starts to conduct. Okay. After this barrier voltage, the diode automatically starts to conduct. And in reverse bias, the supply connections will be opposite. That is, the N type is connected to the positive terminal and the P type is connected to the negative terminal. So what happens here? The positive So here the positive charges moves to the negative and the negative charges moves to the p type. So what happens? Oppositively charged. So they get neutralized here. I mean recombine. So what happens? The depletion region will get increased. Ideally, for reverse bias, the PN junction diode does not conduct. But because of movement of minority carriers, we'll have the currents are in microampere or in nanoampere. Okay, that's all with the operation of PN junction diode. Thank you.